Okay, so for today, how does more advanced AI such as ChatGPT work? So all of you have probably heard of ChatGPT, like ChatGPT now. It's very popular, very famous and stuff. It's very advanced too, probably a lot smarter than us humans in many ways. So sophisticated AI like ChatGPT, it learns to talk and think like humans by analyzing lots of examples of conversations. So I don't know where they got these conversations from, but there's like thousands upon thousands of them. And the AI, ChatGPT, like reads through them and understands how the words fit together using algorithms called NLP algorithms or natural language processing algorithms. And then it gives responses based on what it has learned. So that's just like a brief, I guess, basic point of view of how ChatGPT works. So, oh, and also ChatGPT uses a lot of data. So ChatGPT is fed over 570 gigabytes of data, which is a lot of computers' total storage capacity. And if you don't grasp how much that is a lot of data, since text files are just kilobytes at most. So that's ChatGPT in particular. So what is supervised learning? Supervised learning is a machine learning approach where an algorithm learns from a group of data to make predictions or classifications. It's like teaching a student with a textbook and answer key. So the algorithm learns the relationship between the questions and answers and how they got to the answer. And it does this based on specific examples. And then it uses that knowledge to predict outcomes for new unknown data. And this data obviously can be completely random and not relating to what the AI model has already trained on. It has to be at least somewhat similar to the questions and examples and answers it has already learned with. Otherwise, it won't really make sense. Okay. Any questions about supervised learning? Okay, then. And also the key thing about supervised learning is we give it labeled data actually. So we talked about that yesterday. And like a textbook and answer key sort of thing. So we give it like the answers, the questions, everything, and it learns off of those. And now we have unsupervised learning. So unsupervised learning is kind of like the opposite of supervised learning. It's a type of machine learning. Yeah, it's a type of machine learning that analyzes unknown data to discover hidden patterns, structures, relationships without help and examples. So in supervised learning, it would have lots of questions and answers and labeled data, all these examples. Unsupervised learning would be using unlabeled data, which is just raw data without any description. And it doesn't have any knowledge of the desired outcomes. It learns more independently than in supervised learning. Oh, and by the way, any questions about this? All right, then we'll move on. Okay, now semi-supervised learning. It's kind of in between supervised and unsupervised learning. But semi-supervised learning is a machine learning approach that combines a small amount of labeled data with a large amount of unlabeled data to train a model. It sits between supervised learning, which uses only labeled data, and unsupervised learning, which uses only unlabeled data, as I said earlier. This hybrid approach can sometimes lead to much better results compared to using label data alone, especially when label data is hard to get. Because as I told you earlier, it's expensive to get labeled data, and it's also time consuming for someone to go through all the data, write a small description of it. So sometimes it can be better, but keep in mind this is not always true. Okay, any questions about semi-supervised learning? All right, then we'll move on. Okay, and now this is the last type of learning sort of thing we'll talk about. reinforcement learning. And this is actually used in a lot of softwares like self-driving cars actually. Reinforcement learning is used and in lots of like hardware scenarios and robotics especially, reinforcement learning is widely used. So it's a type of machine learning approach where a model learns to make decisions by interacting with something. So the model gets either rewards or punishments for what it does, and it learns to do whatever gives you the most rewards over time. So kind of like humans. Humans behave in a way that they want the most good to come out of whatever they do. Well, most of the time, but yeah. And that's kind of how the AI is functioning in the reinforcement learning system. It tries to choose actions that maximize its rewards over time. So this process is similar to how humans and animals learn through trial and error. So it's like how when you get good grades, your parents might reward you with, I don't know, ice cream or something. But when you get bad grades, they probably wouldn't reward you. And because you want rewards, you would try to get good grades since you like ice cream and you want ice cream. So that's kind of how a machine learning model learns with reinforcement learning. Any questions? All right, then we'll move on. So next, what is generative AI? Generative AI is a type of AI that has the ability to create new content. So it can create text, images, music, videos, whatever. And it does that by learning from existing examples. So it could come up with new ideas or create something original based on what it has learned. So the keyword here is new. This is because generative AI creates new things, which is actually quite a big breakthrough. And ChatGPT and Siri, uh, Alexa, these are all examples of generative AI. So AI can't be called generative AI if it doesn't make new content. But like all other AI, you can never guarantee that it's going to be 100% accurate. And later in the core, like later in the classes, I'll show you exactly what I'm talking about over here. So how does generative AI work, and how is it different from traditional AI? Generative AI is different from traditional AI because it actually learns from information. So earlier when I said traditional AI doesn't learn from information, yeah, that's the big difference. The keyword there is no learning for traditional AI. And generative AI is capable of creating new content, like I just said. And the way it works is it analyzes the data the way traditional AI does, but it looks at patterns and remembers what it needs to replicate that content. In addition, generative AI requires a lot more data than traditional AI to work more efficiently. So traditional AI, for example, you might need like uh maybe like 500 kilobytes of data. And then okay, well not kilobytes, but like 500, yeah. Okay, 500 kilobytes of data. And then for ChatGPT, I told you earlier, it was fed 570 gigabytes of data, which is a lot more data. So generative AI learns from these patterns to create new content, and it can imagine and invent new ideas, unlike traditional AI, which follows specific rules and instructions without creating new content on its own. Okay, any questions? All right, then we'll move on. Why? Okay, wait, okay. Key takeaways of generative AI. So, new content. This is probably the most important thing. Any AI is not generative AI if it does not create new and original content. So even an AI that like copies completely what someone else did or some other AI did, it's not generative AI. At least a part of it has to be original and coming from the AI. And next, lots of data. Generative AI has to learn off of enormous amounts of data to work accurately. So like I said, ChatGPT requires 570 gigabytes of data, which is a lot of data again. And finally, seeing patterns. Generative AI learns by observing patterns in its data and remembering those patterns. So keep this in mind whenever you encounter generative AI or anyone asks you a question about generative AI. These three are probably the most important, broad, general things that you should know about generative AI. Now, what are some examples of generative AI? Um, okay, there's like ChatGPT, there's Siri, there's Alexa, there's Google, there's AI image generators online, AI audio generators too, pretty sure, AI video generators, and the point is there's a lot of generative AI out there. Okay, and by the way, one more thing, here when I talked about AI, well, generative AI in specific requiring lots of data, it needs lots of data to learn because of seeing the patterns from examples to create new things. So the more data it has, the better it can understand and generate accurate and diverse outputs like text, images, and or music. Because the more data you have, then the more potential for more patterns you have, and you can identify these trends across more data, which gives you a more clear and like more tangible idea of what you have to make if you're generative AI. So since we have machines that are so powerful, people who make generative AI try to train it on as much data as possible to make it as accurate and as good as possible. Any questions about this? Okay, then. Um, we'll move on. Okay, so we just went through this. Siri, ChatGPT, etc. Okay, so part three, deep learning in neural networks. So this is probably our longest part, and it's it's more in depth, and you'll realize what I'm talking about in a second. Okay, so what is deep learning? Deep learning is a part of machine learning. So earlier we talked about a chart with AI ML, and I think you might have seen DL on there or not, but DL or deep learning is a part of ML or machine learning. And machine learning is a part of AI. So indirectly, deep learning is also a part of AI. So deep learning is a fascinating uh, subset of machine learning that's on, inspired by how the human brain works. So to understand a little better as to what deep learning is, let's take a look at this AI generated image of people on a beach, like at a beach, and there's lots of different objects, like this tree or this island in the background, and I don't know, this cloud, the ocean, the sky. And at first glance, it may actually seem pretty impressive. AI generating this is a pretty cool thing, and you can literally generate whatever you want. And it probably would have taken seconds to do this, since AI works pretty fast, pretty efficient. But if you look closely at the minor details and the way they connect, you'll see that some parts of the image don't even make sense. For example, look at someone's face. Okay, so look through all the faces of everyone, and okay, look at this face right here. The one where my mouse sort of thing is pointing. This face. It's like kind of distorted, and this face too over here. This face. This face. They're like weird and honestly kind of disturbing too. So, as you can see, AI is not perfect. As I told you earlier, you can never guarantee generative AI to be 100% accurate. Uh, nothing can really be perfect, and that's the goal we're all working towards. Everyone wants to make AI capable of doing everything perfectly better than humans. So that's essentially what strong AI or AGI is. Okay, so right now, what we are doing is looking closely at the image. The more time and devotion we give to the details, the more information and small features we can process and observe. So, for example, these disturbing faces. That's one of the things.
And the rainbow color scheme.
Oh yeah, yeah, that too, and whatever else you notice. And can you see my
Yeah,
mouse by the way?
yeah, that looks like a camera, a orange camera.
Yeah, like up here. That's what you're talking about, right?
Yeah,
Yeah,
like a speaker or something.
Yeah, like in the tree. That's again, you can't expect AI to be perfect. Sometimes it can make pretty strange results. And the more data you have, though, like the more data you feed to the AI to train on, then the more accurate it's going to be. So, as you can see here, maybe like not all the data in the world was fed to this. And that happened, whatever that is. I think it's supposed to be a coconut, but it doesn't look much like a coconut. Okay. So AI or generative AI does this using neural networks. And neural networks are modeled after how our brain works. So that's pretty interesting. And here's an example of what a simple neural network looks like. Like in the most simple sense possible, this is probably what it is. At first glance, it doesn't seem to make much sense, but don't be intimidated by it because it'll make sense in a second. So picture the first layer or these red circles or pink or whatever color you want to call them as the input layer as labeled down here. And this is going to be our input information. So whatever data we give to the model to train on, whatever data we provided that, so an image, a text file, an audio file, a video file, anything that would be passed to this input layer before anything. So in the context of our AI generated beach picture, the picture of the crowd at the beach would be our input, and it would be first passed to the input layer. Next, that image goes through the intermediate layers or the hidden layers as shown in the diagram. And these are the blue circles. And here you can see it's labeled as hidden layers. So these hidden layers start recognizing more complex features, such as individual shapes or specific objects. So here, Druvin, you pointed out this weird camera speaker sort of looking thing. So AI would start recognizing things like that. Maybe like if it was trained on a specific image, which it probably wouldn't, but it would recognize small details like this tree or that thing or the distorted faces, the rainbow theme, the background with that building over there for some reason, the clouds. All these small features is what AI would start recognizing in the hidden layers sort of section in the neural network. So every intermediate or hidden layer of the neural network builds a more detailed understanding of the basic features identified by the earlier layers. So let's say we were on this layer and we first identified the island in the back. So the island would be passed to this first hidden layer with 4 circles. And then after that, it would analyze that island even more. So as you can see on the island, there's something that looks like a building. I think it's a building. And here in this next section of the intermediate layers or hidden layers, the building would be here. So inside of these small objects, inside of these small features, it would carefully observe these even smaller details and try to absorb everything so it can properly replicate the image. So that's that's how the intermediate layers work. They take easily noticeable things, and this is for images specifically, but they take easily noticeable things and they again uncover small details from them. So similar things can happen in audio files and text files and videos, but like not in the same way. So, for example, in a text file, the AI might analyze a paragraph in the first hidden layer, and then the next hidden layer might analyze a sentence, and then after that, maybe a word, maybe a letter after that, and so on. well, I mean the letter is the last point, but you get the idea. So as you can see in the hidden layers or intermediate layers, there's an incremental increase, well, increase in the level of data acquired. So finally, the image is processed to the output layer. So these two green circles, where it's ready to be used in whatever way necessary. Okay, any questions?
Yes, so you know how in the picture it sort of made that random building in the background, right? So
Yeah,
I think the data that was given to it probably had like pictures of buildings on land. So it probably analyzed that data and tried to make it similar.
yeah, that's exactly right. So as you saw here, when AI trains, it looks at those small details, those big details, like every detail, and it tries to remember that so it can incorporate them into whatever it's creating. So you're
And also
right.
about
Here,
and the
huh?
rainbow, it might have been fed like incorrect information about
Oh,
the so about the rainbow, it might have been fed incorrect information about the color scheme.
yeah, maybe. Well, I mean, yeah, that could be. Bad data is actually like a really common reason as to why AI goes wrong sometimes, and like it doesn't function as intended. And yeah, this could be an example of that.
And also there's a distorted man in the bottom left corner.
Yeah, yeah. As you can see, AI and specifically this AI is definitely not like
Seven
perfect.
limbs is
Yeah,
totally normal.
yeah. So AI is definitely not perfect, and it might not have taken the right data. So if you feed bad data, you're going to get bad results. That's how pretty much all of AI works. And there's other abnormal things like this cluster of whatever this is. I don't even know what that is. And why is there confetti or I think that's confetti on the ground, everything. So yeah, there's a lot of minor imperfections and sometimes they can be major if
It's
there's problems in the data.
it's confetti when in the bucket there's flowers.
Oh, yeah, yeah. Well, wait, is that flowers? I can't even tell. But yeah, it might be flowers. But yeah, as you can see, it's pretty random. It doesn't make much sense. So this can also happen like if the neural network is not like advanced enough, like it might not have enough layers in the neural network to train the data. And we'll talk more about that in a bit. But for now, that's the basic neural network sort of thing. Any other questions? All right, then we'll move on. Okay, so more in depth about like more in depth about these. So uh well, yeah. The deeper layers or the layers that are more to the right, especially in the hidden layers, the output layer doesn't matter. Don't look at that much. But in the hidden layers, the layers to the right, uh they transform low level features, so like through these lines into high level features, like uh features that are more small or not very noticeable, more specific. So, for example, a low level feature would be that island in the background, and then a high level feature would be that building on top of it. Or a low level feature would be this tree, and then the high level feature would be this weird thing, whatever it is. So, those are some things. Okay, and as you go on from the left to the right, in the hidden layers and the intermediate layers specifically, you start to represent more complex and intricate aspects of the data. So this is how we can spot the distorted faces, the island, the building, the trees, and all of these details generated by AI. First, we take the whole image and like we kind of like start to look at the smaller details after that, and then maybe the even smaller details. So for example, earlier we might have seen this bucket, and then later we might have seen, oh wait, what's in the bucket? That's weird. And then same for the island. We might have seen the island at first, then we further observe the island, and then we see the building. So the way that humans work is actually similar to how AI works in this neural network form. And that's because neural networks were based off of AI. Okay, I see we have a question.
Yeah, I do. So, why is why is there a person that looks like that is why does someone have a head that looks like a man, but then it's a girl? Like in the
Yeah, so
right like bottom right corner.
uh okay. As I said, strange things can happen with AI. Actually, especially in like image-based generation, like videos and images, or I don't know, GIFs and whatever image-related data types there are. Things like this are actually more common to happen since there's so many small details in images, especially like intricate images with so many different things like in here. Um, so don't expect AI to ever be accurate in at least this sort of sense. Maybe in the future we'll get an AI that is perfect, with more advancements and stuff. But for now, these features, like for AI generation at least, they can be regarded as common. You might see them across a lot of images. So this isn't very peculiar, like peculiar or strange, and this shows that AI, generative AI isn't optimized. Like it isn't the best. It's still in a very developing state too. Okay, so that's the intuition behind deep learning. It's a complex process that allows machines to learn efficiently by processing information in stages to really look in depth at whatever data is given to the machine's neural network. So let's explore some more technical details to further deepen our understanding. So we call this network, okay, my bad. Okay, actually, let's just look at this image. Okay, we call this network um an ANN, or artificial neural network. It's it was modeled after BNN, or biological neural network, which is actually the true neural networks in our brain, but modeled artificially. So in any AI, if there's a neural network, it's gonna be called ANN. And in a human, in the brain, if you talk about a neural network, it's gonna be called a BNN, or biological neural network. So for now, this is a more complicated example than over here of a ANN, or artificial neural network. So ANN actually works a lot more differently than BNNs in our brain, but some aspects are pretty similar. So like our senses and ANNs, the input layer, so right here, it sends raw, unanalyzed data to the brain. So let's say that our brain is processing a smell. So let's say like we smell some really tasty food or something. And that is raw data that is given to our brain. So then the intermediate or hidden layers in our brain sort of, they process the information, like look at the smell, like try to recognize it and find out, oh, it smells like, I don't know, French fries or something like that. So that's how, very briefly, our brain works, at least in neural networks. So neural networks can actually have one or multiple hidden layers. Usually in AI, generative AI, they have a lot of layers, a lot more than this even. This is very basic. And increasing layers actually increases the complexity of the neural network. So as you can see here, there's a lot more of these lines, and it looks more complicated than something like this, which is very simple, doesn't have many lines. So That's one thing you can see. And adding more layers to a neural network increases the AI's learning capacity. So the more layers there are, the more it can learn, the better it can learn. But the downside is that it needs to be carefully managed to ensure effective learning. So if any one thing goes wrong in this intricate web of connections, the rest could be like also completely destroyed or corrupted or whatever you want to call it. The entire program could capsize, which obviously is not a good thing. Okay, so first we have the input layer, which takes raw data. Then we have the hidden layers that process the data, and then we have the output layer that generates the final result. So every layer of the artificial neural network is made of neurons or nodes. So that would be these little circles here. Each of the circles is called a neuron, or it could also be called a node. For the purpose of this, we'll just call them neurons. Although you can call them whatever you want, it's completely fine. So these neurons are responsible for processing and transforming the information received. So these webs, like these line kind of things, all they're used to do is just transfer the data from one neuron to the other. The actual processing and like analyzing the data, or in our previous scenario, the beach image, it all takes place inside these individual neurons. So these neurons or nodes are again represented by these little circles, if you didn't hear me before. So to understand this even better, let's take an example scenario. Let's say a specific AI model's goal is to recognize handwritten numbers. So even in humans, sometimes we can have very miserable handwriting. And your teachers probably saw this a lot, but there are some students out there which have completely illegible handwriting, and it's like so hard to read, and they handwrite so bad. So that's one thing that actually people are trying to incorporate into AI, recognizing handwriting. So if I go to the next slide, here's an example. Okay, so don't like look at everything yet. Don't process the data yet. Like that this information, this image, don't like process it yet, and maybe like like kind of overwhelming or something. But just listen to me and I'll explain it step by step. So to recognize handwritten numbers, the AI model has to be trained on a database consisting of thousands of examples of handwritten numbers. And it's better if, again, this is label data. So under the image, it tells you what number it is, some description or something like that. So this process starts with the input layer of the ANN receiving an image of a handwritten digit. So here in the inputs, it would receive one or more images of handwritten digits. So you can see this image is made up of thousands. Okay, well, in this case, it's hundreds. 784 to be specific. This is made up of 784 individual pixels that combine to form this image. So each pixel serves as an individual neuron, which is actually pretty interesting. So each one of these pixels, so like this zero over here, that's a pixel. It would be one of these circles. So there would be a circle for every number, over here, which is quite a lot of circles, 784 circles. So you can see that for just such a small task, looking at analyzing handwritten numbers, it still requires a lot of computational power.
Since this is pixelated art, does it have to be like? I think that it's like the darkness of it because like I'm
Yeah,
not seeing patterns.
yeah. So the zero is going to be completely white, and the higher the number is, the darker it is. You're right. Okay, so imagine that for each image, so let's say that this neural network right here took one image. Don't look at these multiple inputs and only took one image. So let's say that it takes that one image. What it would actually be getting is a list of every one of these 784 neurons. So each of these numbers, 784 of them, it would be in an ordered list given to the neural network to analyze, which as a human would be really boring and time taking, but for a neural network, it would have no problem at all. So each of these pixels in that list of pixels creates a number. Well, I mean, contains a number based on how bright or dark the pixel is, like I just said. So again, 0 is white. The higher the number is, the darker it is. So 256 would be completely black. Okay, so basically, inside the list, like I just told you, it contains all these numbers, but it doesn't always have to contain numbers like this. It just it just contains kind of like a value that describes that individual pixel. Okay, so now we can see like all these numbers again, and 0 is white, obviously. And the higher the number it is, the darker it is. Each one of these numbers is called activation. So the higher the number, the darker the content inside a given node. Okay. So first, look at the left-hand side image. Wait, what? What? 1 second. What is happening? Wait, sorry, 1 second. I just don't think the image is loading. Oh, okay. Here it is. Okay. Anyway, look at the left-hand side image first. So each of these x1s, x2, whatever, each of like these elements or things in the list. So x1 would be a thing, x2 would be another thing, x of m would be another thing, and there's lots of other things on the list. In this scenario, there's 784 things on the list. But this is what a list of different pixels would be stored as vertically, and it would be 784 elements tall. And that is obviously very, very, very tall. So we describe the list of pixels length as the neural network's width or height. So let's say we had 784 pixels in a list. There would be 784 blue dots stacked on top of each other, and that's how tall this neural network would be. And that is already very, very, very enormous. So imagine how much bigger it would be for HD images that have like thousands of pixels. It would be very, very complicated to understand. So we're just using this much simpler example. Okay. And also the number of layers, so the number of layers, like the hidden layers, the number of hidden layers, the input layer, the output layer, the number of layers in total is called the depth of the neural network. So it's just how long it is, basically. So the number of layers inside the ANN, again, is called the depth of a neural network. So on the right, you can see this. The neural network is made up of 6 hidden layers. So 1, 2, 3, 4, 5, 6. And an input layer and an output layer. So total we have 1, 2, 3, 4, 5, 6, 7, 8 layers in total. And 6 plus 1 plus 1 is 8. So this means that the depth of the neural network would be 8. Okay. So now we're gonna go back here. And by the way, does anyone have any questions about this?
Can I go to the restroom?
Yeah, sure. I'll wait for you. And meanwhile, does anyone else have any other questions? All right, then we'll just wait for them to get back. Huh?
So after the image like clarifies the darkness of each node or neuron and like pixelated, does it look for Like let's say all it does is recognize numbers. Does it like search like let's say it does it search for like numbers that are matching that darkness or something?
Okay, so basically like before all of this, the AI model would have to be like fed a like a list or a database kind of thing that consists of all the different numbers and what color that corresponds to. So automatically it would like check with that list or database and it know um like what color or how dark it is automatically. Did that answer your question?
Yeah.
Okay. All right, then we'll just wait for Devin to get back.
I'm back.
Okay, then we'll continue. Also, any other questions other than these two? Or I mean this one. Okay. All right, then we'll move on. Okay, so we have numerous connections between these nodes. So all these lines that connect the nodes together, because each layer's nodes, so let's take this specific node. It has a line that connects to every other node in the next layer. So this node and this node, they connect, this node and this node, they connect, and it goes on like that until it's connected to every node in the next layer. So it just cycles like that, and that's what kind of makes it look so complicated. So this extensive network of connections is essential for learning from input data. This serves as mathematical transformations, which you don't need to learn about right now. I I think like you'll learn about that in like middle to high school or something. But uh it's it's very complicated, like behind the scenes there's a lot of math happening. Uh a lot of that's too complicated for us to understand. So we're just gonna let that be for now. But anyway, the total process translates the input via various layers into the output, and it refines or improves the end information before it generates the final result. So let's take that AI generated beach example that we got earlier. It starts from the input layer, gets processed through the hidden layers where it learns to like recognize small details, characteristics, all that. And then it goes to the output layer where it's ready to be used. That data that it got from that image, whatever it learned, now it's ready. So that's the final result. Okay, so this actually involves thousands of repetitions of learning to like discover the final result and like work properly. Okay, so why do we even need several layers though? So when we see an image in the background, our brain connects various components of what it is made of. So, for instance, the number 3 can be split into two elements, a rounded top and a rounded bottom. That mirrors the top to form the number 3. So I'm gonna like find a blank slide real quick. Save this slide. No, annotate. Can you see my annotations? Okay. Okay, so let's take the number 3. So let's think about this carefully. First, we have the number 3, as you can see here in the top left corner. That's the simple number 3. I'm sure all of you know what the number 3 is. Otherwise, that would be pretty concerning. But it's very simple. You probably learned this in like preschool or kindergarten or somewhere very early. But AI actually has to like analyze it more in depth to recognize the number 3. So let's say the number 3 can be split into 2 elements. So AI actually breaks down something as simple as this to learn about it. Okay, so I'm gonna erase this and draw this. Okay, so first the AI might think of, okay, so it's made up of 2 elements. First, this rounded top, and then the rounded bottom that mirrors the rounded top. And this forms the number 3. So AI might break down each individual detail or thing to carefully analyze this and remember what it looks like. So the first hidden layer in our neural network, it might learn to recognize these features from the input data. Then in the second hidden layer, we might continue to build on the information processed by the previous hidden layer. So we've identified edges and curves to the number 3. So now we might be able to use them to derive more specific and complex shapes like loops and intersections. So like over here, we might be able to break it down further. And for us, there's not really much to break down, but for AI, it's definitely more complicated than it looks. So in the first layer, we might recognize these features, and then in the second layer, and then so on, we start to build on these features until we learn everything there possibly can be. So, now when the information has reached the final layer, the neural network has successfully learned to recognize the overall shape and configuration representing the number 3. So it'll successfully be able to recognize the number 3. So it's gonna be like, oh, look, someone wrote the number 3 here. And it's gonna say, okay, this is definitely not the number 3. So that's kind of the process of how it learns, like more detailed. But the underlying behind the scenes process, however, again, it involves intricate mathematical manipulations, which I didn't describe fully, since that's way too complicated to understand. And honestly, it doesn't even serve much purpose for this class, and that would take absolutely forever to explain. And I'm not even like sure I could explain it like that. It's so complicated. That's the point. But in essence, the layers of an ANN through their depth and width, as we have seen here, so depth and depth and width, it all totals together to create a robust system of pattern recognition and data interpretation that mirrors some aspects of human analytical processes, but in a more structured way. So this capability to analyze large, high-dimensional data sets and recognize these complex patterns with high accuracy makes deep learning a revolutionary tool in AI. So that's what's made today's incredible AI advancement possible. ChatGPT, again, Alexa, Siri, AI image generators, though they might not be 100% accurate, they are still very impressive. And most people can't even begin to comprehend how each individual like step at the very base point, like how it's all processed in the computer. So it's very brilliant. Okay, so it took some time to process this information and get to this conclusion. You can expect AI to take that time too, although obviously not as much since AI is a lot faster and it has a lot more computational power. So keep in mind that whenever AI is taking time to give you a response, and especially generative AI, it may be doing something like what we just talked about, so these neural network sort of thing, to process your requests. So don't be impatient. As you can see, what it's doing is very, very, very complicated, especially in those mathematical like operations and stuff. So keep that in mind whenever you work with generative AI. Okay, so that's about the end for today. So today we've covered neural networks, a little bit of generative AI, mostly neural networks and like in depth how each thing in neural networks works, what nodes are, what neurons are, how the process like is carried out. Some examples too. Can everybody type in the chat the most interesting thing they learned today? Also, take your time if you take your time with your responses if you want. We have 2 minutes, which should be enough time for you to write your responses. Okay, neural networks. The most interesting thing you learned. I mean, yeah, it is pretty interesting and very complicated. Depth, okay. This depth thing, honestly, it can be thought about in a way more complex way, but this is pretty simplified, so yeah, that's actually pretty interesting too. And uh Durvin said, okay, so when Durvin said neural networks, yeah, that's obviously what we've been talking about today for the most of the class. So yeah, that is pretty interesting, you're right. And then depth, like I just said, it can be expressed in a more complex way, and there's more to uncover in this, which we won't be talking about since that's way too much, way too complicated. So yeah, that's pretty interesting too. And Tanu said the way that it does it's so quick, but there's a lot of steps to complete it. Yeah, that is probably one of the most like remarkable things about AI. AI can process information, process a lot of steps, like in literal seconds. So that's pretty interesting too. Okay, Satvik said, I learned about what artificial neural networks are like and how they work, also what the steps are like, the input and hidden layer and the output. Yeah, it is quite a lot to take in, and it's kind of fascinating to know that AI actually does something that's a lot more complicated than this with those mathematical transformations behind the scenes. So that's pretty fascinating too. Did we receive a response from everyone?
Not
Okay.
yet. I'm still typing my response.
Oh, okay. Yeah, take your time. Okay, Driven said really BNN. Okay. Biological neural networks. The way the brain works is actually even more intricate and complex than the way our what's it called? Like current yeah, like the way our normal neural networks work. The brain is like made of so many webs of neurons and with the nerves connecting everything together and all these different senses. Uh, it's one of the most mysterious things. And scientists are still like trying to study it to maybe incorporate this in AI. Okay, the most interesting thing we learned today was the example of the number 3, and that the AI can have an infinite number of hidden layer ones. It keeps decreasing the number by the hidden layer until we have one output, which is either hands down incorrect or correct. Yeah, that's exactly right. And it is kind of interesting how just in the number 3, it can go like so in depth and like analyze each individual pixel, even though for us humans it's really not that complicated on the surface. Okay, so that's the end of class today. Uh, have a nice day. Bye.
Bye. Thank you.
Yep.